Hello and welcome. My name is Stephanie, and today we're going to continue with our practice set about finding distance. We're going to be using our equation distance is equal to rate times time. So let's get started. So our first problem asks us to find the distance when we have a train that travels at a rate of 50 miles per hour for 2 hours. Okay. So we're going to write our equation down here, distance. I'm going to write it all out, but for the following examples, I'm going to use the distance equation with just the r and t, okay? So distance, we're asked to find distance, we're given a rate, and we're given a time. So I'm going to write those off to the side so that I know what exactly I'm going to be using. So from the problem, we said that rate is equal to 50 miles per hour. So you want to make sure that you write that down and you include the units. Then our time, we were told, was 2 hours. So I write 2 hours here. Notice that our units for time and the units for rate on the denominator are hours, so we do need those to be the same. That's a hint for the challenge question at the end of this lecture, so keep that in mind. So now we're going to substitute. So this was our first step. Our second step is to substitute, so now I'm going to be using the variable. So d is equal to r times t. So now I substitute for that. R, we said, was 50 miles per hour, and time was 2 hours. Now we carry out the multiplication. So we say d is equal to 50 times 2, which is 100. Our hours cancel. That's why it's important that we have the same units for time and rate here in the denominator. And we bring down our units, miles. So this is the answer for a train that is traveling at a rate of 50 miles per hour. For 2 hours, it will have traveled a distance of 100 miles. Okay, go ahead and jot this down so that we can move on to our next example. For our next example, we have a soccer player who runs at a rate of 5 feet per second for 10 seconds. And we're asked to find the distance. So again, I'm going to write my distance formula. So distance is equal to rate times time. Now I want to find my rate. What is r from the problem? The rate is that he runs or she runs at 5 feet per second. So 5 feet per second. And the time, t, will be 10 seconds. Okay, now I can substitute that in. So d, which is distance, r will be 5 feet per second, and time will be 10 seconds. Now we carry out our multiplication. So distance will equal to 5 times 10, which is 50. Seconds cancel, and we bring down our feet, the unit of feet, okay? So this is our answer for a soccer player who runs at a rate of 5 feet per second for 10 seconds will have run 50 feet. Go ahead and jot all of this down so that we can move on to our next example. So for this example, we have a horse. A horse trots at 5 kilometers per hour for 2 hours, and we're asked to find the distance. So what is the first step? What are we going to write down first? The distance formula. Okay, so we're going to write d is equal to r times t. Now what are we going to do? We're going to extract our information. So what is the rate? What is r? So it would be 5 kilometers per second. Or you can write seconds like this. What is our time? What is t? 2 hours. Okay. Now you see, oh, sorry, per hour. I apologize for that. I was still stuck in the previous problem. 5 kilometers per hour. Okay, you see that? So you have to pay attention to the units here and the units for time, because if they're not the same, then you're going to have to convert. So we have our rate, which is 5 kilometers per hour, and our time is 2 hours. And now what are we going to do? We're going to substitute it for our variable. So R, we said, was 5 kilometers per hour, and our time was 2 hours. We do the multiplication, so we have 5 times 2 is 10. Our hours cancel, and we bring down our unit of kilometers. So this is our answer, so that when a horse trots at 5 kilometers per hour for 2 hours, the horse will have traveled 10 kilometers. Okay? So go ahead and jot all of that down so that we can move on to the next example. For this example, we have a race car, and the race car driver goes at a speed of 150 miles per hour for 2 hours, and we're asked to find the distance. So for the first step, we're going to write down our distance equation. Distance is equal to rate times time. Then off to the side, we're going to write what is our rate given from the problem. Our rate is 150 miles per hour, so I'm going to write that down just so that I can make this easier for myself and so that there's a lot more clarity in terms of what numbers I'm using, which is a good skill to have when you're taking exams and you're doing word problems, being able to extract the important information. And time we read was 2 hours. So this race car driver is traveling for 2 hours at a rate of 150 miles per hour and are asked to find the distance. So now I'm going to plug all of my values into my equation. So rate is going to be replaced by 150 miles per hour times, and we said time was equal to 2 hours. So I'm going to substitute 2 hours here. Now we do the multiplication. So we have 150 times 2, that's 300. Our hours cancel here and here, and we are left with miles. So when a race car driver is going at a speed of 150 miles per hour for 2 hours, they will have traveled 300 miles. Okay, let's go ahead and move on to the next example. And I hope that you are getting a lot of practice with this. So let's read the next problem. A plane travels at a speed of 360 miles per hour for 3 hours. Is that 3? Yes, for 3 hours, and we are asked to find the distance. So I'm going to let you try this one on I'm going to let you try it on your own, and then we can come back and work on it together. Okay, so hopefully you got a good crack at that. So let's go ahead and begin with our first step, which is writing out the distance formula. So it's going to be distance is equal to r, rate, and times t, time. Now we're going to write our values for r given from the problem. So r is going to be 360 miles per hour. And time is going to be, we're told, is 3 hours. Okay, now for the second step, we're going to substitute these values into our equation. So R, we said, was 360 miles per hour times time, which is 3 hours. Okay, now we do the multiplication. 360 times 3 is going to be 1,080. Our hours cancel, and we're left with miles. Okay? I hope that you got the same answer. And if you didn't, maybe go ahead and look back what values you chose for R, what values you chose for T. Maybe go ahead and see if we have the same equation or if you are doing the multiplication the same. There are many different points in this problem where there can be a lot of confusion, so go ahead and compare your work if you have any doubt. Okay, so let's go ahead and go on to the next problem. So we are asked to find the distance as a student walks at a rate of 7 feet per second for 2 minutes. Now let's begin our first step, which is writing our distance formula. So d is equal to r times t. Now we're going to write what is our rate given from the problem. So we are told that it is 7 feet per second. And our time is 2 minutes. Interesting. We have minutes up here and we have seconds down here. So what I am going to do, what I'm going to ask you to do, is to convert minutes to seconds. And how will you do that? Well, we know that there are 60 seconds in 1 minute. So we want time in seconds. So this is how you would do it. You would write 2 minutes up here. You would write 2 minutes and we would multiply it with this. So we would have minutes at the bottom, 1 minute, and 60 seconds at the top. And now, if you notice, the minutes will cancel, and we multiply 2 times 60, and that will be 120 seconds. Now that we have the same unit of time as rate, we can continue to do our multiplication. You could also do this conversion within the problem itself. And if you would like to see that, I would be happy to show you. So let's go on to our second step. So now actually up here, we're going to write 2 minutes is also equal to 120 seconds. Okay. So let's go ahead and now plug in our value. So D would be equal to R, which we said was 7 feet per second. And our time is 120 seconds. Okay, so then you would go ahead and multiply that out. I'll give you a second as I too am going to calculate this. 120 times 7 is going to give us 840. So our seconds would cancel and D would be left with, distance would be 840 feet. This would be our solution. Whoops. So when we have a student that is walking at a rate of 7 feet per second, after 2 minutes, they will have walked 840 feet. Okay, hopefully all of this made sense. If you have questions about the conversions that we did up here, or why is it that we had different units, and why did we have to convert, you know, maybe you wanted to convert seconds to minutes up here. You could do that as well. It would just be a different approach. Hopefully you jotted all this down. We're going to move on to the next slide. So we have this question that asks us, How many miles does Allie travel if she drives for 5 hours at an average speed of 50 miles per hour? Now, this question, although is not asking us to find the distance explicitly, it is asking us to do the exact same thing. So our first step will be the same. We will write our distance formula. Distance is equal to rate times time. And we will write what our rate is given from the problem. So the rate would be her average speed, which we're told is 50 miles per hour. And we would also write our time, which she travels for 5 hours. Okay. And now for the second step, we plug all of these values into our equation. So we write D is equal to R, which is rate we said was 50 miles per hour, and time we were told is 5 hours. We carry out the multiplication, so 50 times 5 will give us 250. And we cancel our hours, and we're left with miles. Okay? Now, this question, I chose it because it's not so explicit like the ones that we did prior, where it's asking us to explicitly find distance. Usually, this would probably be something you would see on a test because it would actually try to trick you into thinking that you were doing something different, but it's actually the same thing. Okay, so hopefully you found this helpful, and if you have any questions, please go ahead and let me know, and I'll be happy to get to it. And now we're going to do a bit of review for this problem for perimeter. We're told that the lengths of the sides of a triangle are 5 centimeters, 9 centimeters, and 8 centimeters, and it's labeled over here to the right-hand side of your screen. And we're asked, what is the perimeter of the triangle? Do you remember what the formula for the perimeter is? Because that is the first step. Or what is perimeter? Ask yourself, what is perimeter? What are we doing when we talk about perimeter? We're adding the sum of the lengths of the sides. Good. So we're going to write perimeter, and last time we wrote it as side 1 plus side 2 plus side 3. But if you understand that all that we're doing with perimeter is adding the lengths of the sides, you don't need to write all of this out. But I choose to write it out so that everyone understands what we're doing and so that everyone can follow along. So now we look at our figure to the right and we see that, this side is 5 centimeters, this side to the side to the left is 8 centimeters, and this side is 9 centimeters. So all I'm going to do is just add all 3 sides. So I would write perimeter is equal to 5 centimeters plus 8 centimeters plus 9 centimeters. Okay, so then we would do our addition. So 5 plus 8 is 13, plus 9, that would be 13 plus 9 would give us 22. Okay, and that would be our perimeter for this triangle. Okay, we're going to move on. Now we have another distance word problem, and this one is going to use our what we talked about last time to convert minutes to hours or to convert units. So I'm going to actually let you tackle this one on your own. The answer for this will be in the description box. So go ahead and check your answer. Remember, I will start you. I will kind of start you off. Remember, we're going to write our distance formula. So you're going to write D is equal to R times T. I want you to look in the problem, and I want you to write what is your rate. Remember to include your units. What is your time? Remember to include your units. And when you get to this part, where you need to convert, I want you to use this conversion factor. So your conversion factor will be you can say 60 minutes in 1 hour. Okay? I want you to use this. This also means this. It can mean in 1 hour, there are 60 minutes, or it can also mean 60 minutes over 1 hour. Okay, and you are going to have to decide which one of these two fractions you're going to use. Okay, so you're going to start like this. You're going to write time, and you're going to write whatever value you have, let's see, here. As you do here, this is going to be the same number, and then you're going to multiply by your conversion factor. And remember what we did here, something had to cancel. So our units had to cancel, remember? So go ahead and try that one out. I know that you can do it. It's just a little bit of work for you to do outside. And then when you figure it out, you can share it with everyone how cool it is, okay? So let's go ahead and continue. And that is the end of our presentation for today. Next time we will discuss exponents with an emphasis on evaluating powers and evaluating variable expressions. Thank you so much for your time and attention today. I really do appreciate it. And hopefully you're able to join us for the next video lecture. Overall, that's it for today, and I hope that you enjoy the rest of your day.